And I am Matteo Collina, and today I'm going to demonstrate a new way to profile Node.js, the clinic toolchain. First of all, we need a very tiny Node.js server that we will start to optimize. So this file called one.js. It's a tiny Fastify web app that offers one route built on top of the Mongo.js driver. So first of all, we need to establish what we call a baseline. So check what is the performance, the throughput of our web application. And for doing this, we use AutoCannon. AutoCannon is an HTTP 1.1 load tester written in JavaScript on top of Node.js. And AutoCannon can also be scripted in Node, so you can actually develop complex scenarios and things like that to actually load test your HTTP-based application. So let's start this. It runs for 5 seconds with two concurrent connections. Here we go. Whoa, 1.2 requests per second. Maybe it's a little bit slow. So the clinic toolchain, this a longish readme. So the clinic toolchain allows as a one command called doctor, and we can ask the doctor what's the problem in our web app. So for doing this, we use this onPort flag that will run automatically our AutoCannon test whenever the node server is started. So here we go. We are running our doctor. It's working. Now it's analyzing data, and here we go. So yeah, I can smaller this thing up. So you can see here that we have some CPU spikes, but overall very low activity and very low memory usage. So maybe something is going on that's not proper, right? So let's move this down here, probably better. So let's go back to our shell. So in order to profile this, we recommend for I/O issues, Doctor recommends the use of bubbleprof. So here we go. We are running bubbleprof, and the syntax is exactly the same, just reach Doctor with bubble, and same process. It analyzes the data, and then it generates the result. And here we go. So we can see a couple of things very interesting here. I'm closing this again. So we can see that there is a big Mongo.js part here. And in fact, you can see that there is one trunk, and you can see it gets highlighted, and then another trunk, which is the second part. So this means that we have that our requests are blocked into this. Our request generates these two very high asynchronous waits of 3.1 seconds. So we can see here that this is causing this delay. It gets started in line 11. So let's go and see what's in line 11. And in line 11, there is a query to MongoDB. Whoa, a query to MongoDB. So here it is. Well, we can copy this, and we can go to Mongo, and we get our database, and then we get our collection. Ooh, and our collection is modules, and then we do our find with our limit, and you can see from this call that it takes a little bit of time, and we can actually ask Mongo why this is low with the explain command, and you can see from in here that it's actually performing a full sort of our collection, which is kind of slow. So maybe we can check. Maybe there is something that can help us in this database. Maybe because adding an index takes some time. So there is a new collection called modules indexed in our database. So we can use that instead, maybe. And let's check what's the query plan for that. And in fact, you can see that there is an index, and we are performing a scan on the index, and then a limit, and then a fetch, and then a limit. Ooh, yeah, this is going to be fast. So yeah, this is faster So now we can switch to true.js file, which is use the new collection instead, and let's see how this performs. So we need to check again. We run this, and then we run autocannon again. Let's see how it goes. So takes a while. In the meanwhile, you can still see me. Hey, here I am. So it's just 36 requests per second. Might not be fast enough. So let's see. Maybe it's related to the 100 concurrent connections. So if that's the problem, let's try raising that to 100, from 2 to 100. So maybe that's what it is. Still 39. So maybe it's still something off here. Let's ask the doctor again. So we have the doctor, and we can ask the doctor. So hey, but we'll update these to 100 concurrent connection. So as we did before. So because yeah, still something off. Let's see. It's running. It's crunching. Yeah, it takes a while always. Hey, so it detects a potential event loop issue. You can see this blocking here. Ooh, this doesn't look good. So it recommends to use Clinic Flame. So that's what we'll use. So we go back here and we swap this. We swap Doctor with Flame like we did before with Bubble Prof. And you can see now that's same process and generating data. Takes a while, as always. Here we go. I'm closing this. So you can see here that we have the compute magic part, and this goes to 85%. And yeah, what it is. Yeah. So I've lost use. I've lost us. So here we go. Hey, here I am. So yep. So you can see here that we spend most of our time in doing the compute magic part. So so the compute magic, it goes at 80%. Well, what is this doing? So we open up our 2.js file, and you can see that this compute magic, doesn't look good. We are creating a hash, then adding things to updating it with 100 times with the same content. Might be not really an interesting thing to do. By the way, this represents a lot of the patterns of typical enterprise applications, and this is kind of bad, but that's what it is. Because there might be some code left in there that slow things down, that might not be even needed anymore, because it evolved like this over time. So we can completely remove the compute magic field, and just return newest and oldest. So let's see how 3 performs. So we run 3, and then we run autocannon again, and let's see how it goes. Takes a while as always. Well, way better now. So we can check with the doctor. Oh, yeah, I don't want to type all of it. So here we go. We can check with the doctor how it goes. And what the doctor says. The doctor reports detected no issue. Oh, this is perfectly good. So yeah, our job is finished. Let's check to be sure. Let's check with Flame and Bubble Prof. So let's check it with Flame first. Maybe there is something else we can optimize. I don't know. Oh, so the hottest path is this magic, which is socket write generic, which is like, it's cool that's at the top. That's very hot, because it means that if this should be if this is the hottest method, we are doing good. But however, there's a lot of other things happening. So for example, this is plenty of hot, and it's a serializer for Bison. So it's probably related to serializing stuff and sending our query to MongoDB. So maybe there is a native Bison driver that we can use instead to make this faster. I don't know, maybe. But I'm not looking into it right now. I'm satisfied with the current performance that I'm having. Yeah, let's also check it with Bubble Prof. here we go. So you can now see that there is a lot of, compared to this was the previous one. Oh, yeah. This was the previous one, and this is the current one. You can see there is a lot more things happening, and we have in fact two mega query, and on this step happens most of the time, and this step as well. So basically, it's we have query running all the time for these two things, and it's actually plenty of good. We are still waiting, spending some time in MongoDB core like this. This is very interesting to see that we have this work being done in within Mongo, that it makes probably can be optimized, but it's between Mongo.js and MongoDB. Is not really on us, on our application, and also we are plenty of satisfied with the performance. So yeah, should be cool. You can see it over here, overing out of this part, so you can actually see it here. So basically, you can see where every part is happening. So it's very interesting. So, and there is something happening always on Fastify, but this is the typical part from the connection listener in Node.js, so it's fine. So yeah, our application is good, and it's fast enough. So with this, I would like to thank you all for watching this, and see you next time. Bye.